Okay, so this is a quick look at the data nodes. What the data nodes basically do is they send their heartbeat to the name node. That's what they keep doing, saying that we are alive. So when you add a new data node to the cluster, they usually say you have to add equal, like similar data nodes to your HDFS cluster. The reason is because you want to avoid skews. You do not want data to be you don't want a, a weaker machine to be overloaded with a lot of data. So they always suggest having similar or same machines to be added to the fleet. This is very typical of a HDFS processing. But if you look at Spark in general, we have used very discrete machines for compute only. We've not used, but that's completely compute processing because our storage is inside S3, which is another file system, which is just a cold storage. You're not doing anything with it. But in a typical HDFS system, you're asked to add all the data nodes which are of the same capability. So you can see like if you see, they are pretty much of the same capability. That's what they're trying to explain here. And when you add new data nodes, they send their heartbeats to the name node. And this heartbeat actually tells the name node that this data node has been added to the cluster. And it also sends very regularly or frequently the block report, and based on the block report it identifies if any of the blocks have got corrupted. If they got corrupted, then it will redo those blocks into another machine so that you do not lose the data. So there's always a very strict rule saying that you can't have replicas, all the replicas on the same node. So if you most of the replicas are always distributed because the likelihood of a machine crashing is high. So you don't want to lose the data and the replicas. So that's the reason what they do is they actually have only one replica in one machine. But however, there is another concept that has been built, which is called rack awareness. So you can have multiple racks of racks of nodes attached to your HDFS. But the good part of a rack is all the machines are closely connected. So the networking, so the movement of the data between the rack is the network latency is very, very less. So right now, if you do the rack awareness, the data is most likely going to be stored. The replicas are also going to be in the same rack. The the likelihood of a rack failing is way less than a likelihood of a machine failing. So you're going to get the replication capability that you're looking for, as well as the less network latency and faster processing if you use rack awareness. So that's what this guy is trying to explain. There's a rack here, and there is a rack here, and there is a data replication. If you do not want to or everything to go into the same rack, you can also, there are also policies that you can set up so that it goes to a different rack. So that I will explain in the sessions as I go. So this is the high level of how the system is looking that looks like. So a little bit more detail on the block replication. So this is what they try to explain. So the one block is in this node, and there should be another one block. So give me 1 second. The second block is in 3 nodes. The third block is in 3 nodes. So if any of them is missing one, then the name node makes sure that that third block has been created based on the processing speed it could. So there is a background processing that always happens, and it keeps processing that, and it keeps moving those data sets into it. So this is explaining the rack awareness. If the replication factor is greater than 3. So usually if the replication factor is less than 2, that means you do not have copies. If the replication factor is 3, that's when you have multiple copies. That's what the way it works. So the rack awareness is a simple but not a non-optimal policy wherein you put unique replicas on unique racks. So this is what it says is a simple but non-optimal policy, because if you start putting data on different racks, you're moving data across the network bandwidth, and that has a lot of latency involved. So that's what they're saying. So usually they try to put it in the same computers in the same rack so that you do not have a lot of network latency, but you still have a lot of replication available. And let's look at the storage types and storage policies. So there are, if the data is hot, if it's available for both storage and compute. So most of the data that you put in HDFS is hot, unless you want to archive it and make it cold only, which is this. Cold is when you want to make it archive. So these blocks are, you can actually mention the storage policy on them as cold, saying that you do not want this data and it has to be, is just meant for archive. So, and this one is warm when some of the replicas are in hot and some of them are cold. Some of them you can compute, some of them are been archived. So usually people do these three in a typical HDFS system. SSDs are, I do not know how many of you have really looked at SSDs and hard disk HDDs in your experience, but SSDs are very expensive. For a typical corporate to buy all these SSDs and put them into their HDFS systems, it costs a ton of money. On Amazon, you keep adding EBS volumes with SSDs because they're very cheap on an Amazon, because you're paying them on an hourly basis. You're not actually spending a lot of money on the hardware cost upfront, because you're actually renting them for a certain amount of hours or whatever. So you do not see the cost involved. But in a typical enterprise, people don't have so many SSDs everywhere. So our cluster, which is built on whatever, has all HDDs. I don't think we don't have SSDs, because SSDs are faster and also expensive. So all SSDs means everything is storing on SSDs. One SSD, one replica goes into SSD. These are different strategies that are available, but not a lot of them have been really used. As far as the storage policies are, you can read the storage policies, but these are the most commonly used storage policies. One is hot, cold, and warm. And what thought of talking about transparent data encryption? 1 second. There's one more piece. Yeah, transparent encryption. So this is one more aspect. When the data gets stored in your HDFS system, you want data. There are constraints wherein some enterprise want data to be encrypted at rest. So there are, I don't know how many of you are really aware about different levels of encryption. So the first level of encryption is encryption at rest, wherein there are, even in encryption at rest, there are multiple levels of encryption. First level of encryption is your SSD volumes are, like, your hardware device is encrypted. That's the first thing. The second thing is your file system has levels of encryption. The third thing is the application level encryption. Don't worry about the database level encryption here, but just look at these three levels of encryption. Your disk is encrypted, which is your EBS volumes or your hardware devices or whatever. They are encrypted at rest. The next level is your file system provides encryption, and the other one is the application level encryption. So by transparent encryption, what it means is your blocks, whatever the data blocks that you're storing inside your HDFS system, they are encrypted using a special key which is available in your key vault. So a vault is a location where you keep your keys for encryption, and you keep rotating those keys very often. So the moment you rotate the keys, all the blocks which you have encrypted using those keys have to be re-encrypted. So the first thing that is very important for data storage, if you have confidential data, is disk level encryption. So most people just do it. They have encrypted volumes that they put in. That is the basic infrastructure setup. But apart from the encrypted disks that you have, you want to save encrypted data. Let's suppose you want the data also to be encrypted. That's when you use transparent data encryption. So what happens during transparent data encryption is, when it's saved on, the blocks are saved on your file system, they're encrypted. But when you go retrieve them, the process actually decrypts that data and gives you a data as though it's not been encrypted, and you can see clear text. But once it's on the disk, it's encrypted. So that's encryption at rest. Encryption at transit means when the data is moving between your networks, like HTTPS, SSL, and all that stuff. That's encryption in transit. That transit level encryption is provided if you set up your yarn to use HTTPS and all that stuff. So in typical enterprises, they definitely do encryption at rest and encryption at transit. So assume that in most systems you have these two. Even in our small company which I worked back in the time, we did both encryption at rest and encryption at transit, just to make sure that the data has not been stolen or manipulated or whatever it is. Though we are sitting in our own network and all that, because you also have internal attacks wherein somebody is trying to attack your data and take your data and leave the company. You have all forms of attacks, so you should always be looking at all forms of encryption in that case. And here he clearly says that file system level encryption and disk encryption are only are only for OS level attacks. But once they get access to your operating system and this, they can actually get the data. But if you do the next level, which is the transparent data encryption, you can actually do the next level of encryption. So this is a very high level about the transparent data encryption that's available in HDFS. The same thing is available on S3 and other places wherein the buckets are encrypted and the data that you store are also encrypted. And you can have your own keys or you can have Amazon or Azure keys. So there are all sorts of like mixed match capabilities that are available with the data encryption and the safe. So I will stop the session here because today I think is a tricky day, but I will continue tomorrow. Tomorrow is a holiday for us, so hopefully everything is gonna be easier.